All right, hey guys. So for this video, I'm going to be walking you through our notes for lesson 5. So you want to be turning to page 16 in your packet. Lesson 5 covers 2 pages, so it's page 16 and 17. And I'm just going to be walking us through all of the examples, some more definitions, some more theorems. If you can do all this on your own and you've already checked the answer key and you're like, yeah, I'm good, that's great. But if not, definitely watch this video as I walk you through step by step what we're doing. C block, just a note, lesson 4, we will backtrack and cover lesson 4 when I return next week, but it's totally okay to take this a little bit out of order. So E block, I know we've made it through lesson 4. C block, we've only made it through lesson 3, but you're going to be fine skipping to lesson 5 and then we'll backtrack. So let's take a look at number 1. So we are given that circle A and circle B are tangents with radii of 6 centimeters and 2 centimeters respectively. Okay, so that means I know that the radius for circle A is 6 and the radius for circle B is 2. Okay. Well, we also know that those radii are showing up in some other places. So we can see right here there's a radius of 6 and right here there's a radius of 2. And so if we know that CD is tangent to both circles, that means we can start to throw in some 90-degree angles here. This is a tangent line. We've got 90-degree angles there. And we're asked to find the area of trapezoid ABCD. Now I know this is a trapezoid because I can see those are parallel bases with those two 90-degree angles on either side. And so if we're asked to find the area of a trapezoid is the height times base 1 plus base 2 over 2. You guys saw that in your recent homework quiz. So what I need to be figuring out is, all right, well, do I know the height? Do I know the bases yet? It looks like we already know the bases. We know one of the bases is 2 and the other is 6, but it's the height that we're missing. So this is actually what I'm looking for right here. I want to see if I can figure out that height, all right? So I don't know h yet, but I do know the bases. So in order to get that height, in order to get this segment here, I've basically just drawn in another perpendicular. I've drawn in something that creates a 90-degree angle right here, and therefore that ends up creating a rectangle. So I've got a rectangle attached to another right triangle in that diagram. And so if this is a rectangle, then that means this little piece here is 2, which makes this piece 4 if that radius is 6. And so what I end up getting is this right triangle here that I'm going to pull off and redraw, where I've got one of the legs is 4. There's a 90-degree angle. I don't know what that height is. I don't know what that length is, but once I solve for it, that'll be the height of the trapezoid. And I know the entire length of the base of that right triangle is 6 plus 2. It's the 2 radii put together. So the entire base of it is 8. And so from here, it's Pythagorean theorem to solve for h. So it's 4 squared plus h squared equals 8 squared. I know you guys can do the math. So once you figure out what h is, you should be getting h equals 4 root 3 when you actually simplify. So once we know the height, we're plugging in. We've got 4 root 3 for the height times 8 divided by 2. And once you simplify that down, you end up getting that the area of the trapezoid is 16 root 3. All right, so that's number 1. Let me know if you guys have questions about that on Tuesday. I know that this might be a little hard to see, especially like with the size of this diagram, but I'm happy to go through this again and check out that answer key on Schoology. All right, so number 2, use the diagram to identify 2 of the following for each of these terms. So there's more than one right answer for a lot of these. I'm just going to point out a few of them. Very first thing, a central angle. A central angle originates from the center of a circle. So, for example, right here, this would be a central angle. The vertex of that angle is the center of the circle. And therefore, one example of a central angle in this diagram would be angle BEC. We're asked to find 2 of each, so another central angle in that diagram could be right here. Angle AEB with the vertex at E. Angle AEB. Those are central angles. All right, then you're asked to identify a semicircle. Now, I don't think this is something I super emphasized when we covered this in lesson 1. When you're giving the name of a semicircle is neither a minor arc nor a major arc, but if you're indicating a semicircle on the bottom of this circle, you need to actually give 3 points for the arc so that you can indicate the direction the semicircle is going in. So this semicircle here has endpoints of A and C, and it hits point D. So one example of a semicircle in this diagram would be this, arc ADC, that's a semicircle. Likewise, you could also do semicircle arc ABC, and that would indicate the semicircle along the top. So 3 letters to name a semicircle. When we're moving to a minor arc, remember we said minor arcs are less than 180 degrees. So a minor arc would be something like this, arc BC. For minor arcs, you only need 2 letters to name them. Another minor arc in this diagram then would be right here, arc AB. Just 2 letters to name it, throwing that little arc symbol on top. And then finally, to name some major arcs. So major arcs, more than 180 degrees, bigger than a semicircle. So an example of a major arc in this diagram, let's say that we started at A and we went all the way to B. So this right here, we could call this arc ADB. We could also call it arc ACB. Totally up to you. ADB. You could also do arc ACB. Those 2 names are for the same exact arc. If you wanted to give another major arc in the diagram, let's say that you wanted to use the points A and D and wrap around the circle this way, you could say arc ABD, or you could say arc ACD. These are the same exact major arc, we just have 2 different names for them. It's that middle letter that's changing to indicate the direction. So that was your do now. Moving into a little bit of vocabulary down here. Okay. So, the conceptual meat of this lesson, talking about arc measurements of circles. And so there's like 3 key things that you need to know. Very first thing is that the measure of a minor arc, so an arc that's less than 180 degrees, just to make sure you guys can see this. Yeah, kind of. I should probably change the color or anything. The measure of a minor arc is equal to the measure of the corresponding central angle. Can we see this? Kind of. Okay. So the measure of a minor arc is equal to the measure of the corresponding central angle. So what does that mean? So if we take a look at this diagram here, here's a minor arc in the diagram, arc BC. The measure of arc BC, let's take an example of this. The measure of arc BC is equal to the measure of the central angle it intercepts. So an angle originating from the center of the circle. If the central angle is x degrees, that means that arc BC is also x degrees. And it's the same thing as the measure of angle BEC. Those are equivalent. Okay. So if we know about the measure of a minor arc, let's talk about the measure of a semicircle. So the measure of a semicircle is always 180 degrees. Half a circle, full circle is 360. Semicircle, half a circle, 180. So for example, in this diagram, semicircle ADC, the measure of semicircle ADC, right? 180 degrees. That's equivalent to the measure of semicircle ABC, right? So one semicircle along the top, one along the bottom, 3 letters to name it. All right, I don't think that's anything like earth-shattering to you guys. So we've talked about minor arc, we've talked about semicircle. Let's talk about a major arc then. So measure of a major arc. Is equal to 360 minus the minor arc it intercepts. So an example of that, in the case of this major arc here, major arc BAC, if I wanted to get the measure of major arc BAC, I would take the full circle of 360 and subtract off x degrees, which is that minor arc that creates, or the addition of which creates that full circle. So that would be 360 minus x degrees. That would be the measure of arc BAC. Okay, so I think that's everything I need to cover here. We have one more example on this page, so I'm going to shift this up, and then we're going to go through example 1.
Or Dave Turcotte, if you're in the building, please call 6203. Thank you.
Okay, so 2 points on a circle determine a minor and major arc. If the measure of the major arc is 39 less than 12 times the measure of the minor arc, what is the measure of the minor arc? So although you can just jump right to the algebra with this, I think it would be helpful to at least draw a diagram so we know what we're looking at. So let's draw ourselves a circle. And we know we've got 2 points on the circle that will determine the major and minor arc. All right, so let's call this, what did I call it on my notes? B, I'm going to put point A back here, and I'll put point C here, all right? So we've got circle, I don't know, we'll call it circle O, and B, C, those 2 points, those create the minor arc. And the major arc, those are the endpoints, and I need that extra point there so that I can name the major arc. All right, so if I want to find the measure of arc BAC, that's the measure of the major arc. Let's see what I'm told. I am told that the measure of the major arc, so this, is equals 39 less than, okay, so I know that when I see 39 less than, that means I'm going to have to subtract 39 from whatever expression I'm writing. 39 less than 12 times, so 12 being multiplied by the measure of the minor arc. So is means equals. 39 less than, I'll eventually have to subtract 39. 12 times, so 12 multiplied by the measure of the minor arc, BC. And then I'm going to throw that subtraction in, minus 39. So when I pull all this together, the measure of the major arc equals 12 times the measure of the minor arc minus 39. Okay, so that's my first equation I'm working with. Now I think it might be helpful at this point if I maybe let the minor arc be x and I let the major arc be y, so that I can just throw some variables in here. Y equals 12x minus 39. We're creating a system of equations. And then from there, I also know definition of a major arc. The major arc is 360 minus the minor arc. So I also know the measure of arc BAC is 360 minus the measure of arc BC. In other words, I know that y is the same thing as 360 And so from here, here's your system. An equation with x and y, an equation with x and y. Since they're both set equal to y, you can set them equal to each other through substitution. Y equals this, y equals that. That implies 12x minus 39 must equal 360 minus x. And so this is just basic algebra. And when you solve, you should be getting that x is equal to 399 over 13 degrees. That would be your exact value for x. And that's approximately 30.7 degrees. So that's the measure of the minor arc. That's x. Now let's double check. Is that what they were asking for? What is the measure of the minor arc? Yes. Final answer. That would be approximate. That would be exact. Okay, how am I doing on time here? Oh, not too bad. All right, let's turn that page. Flipping over to page 17, I'm going to give you guys a theorem. So we've got a theorem to cover, a little bit of calculation to do, and then a final proof here. Now again, if you want to try all this on your own, see how you do, and check the answer key without watching this video, great, go for it. So the theorem I need to give you guys is the arc addition theorem. We're going to draw a diagram to go along with the theorem itself. So you're going to draw a circle, and in that circle you're going to draw 3 radii. One to A, one to B, and one to C. And the arc addition theorem says that the measure of arc AB plus the measure of arc BC is equal to the measure of arc AC. Now, because AC is a minor arc, I don't have to name it with 3 letters. But if this were much larger, right? So let's say I made another point here, and I called this D. Let's say we had the measure of arc AB plus the measure of arc BD. AB is a minor arc, BD is a minor arc, they're both less than the semicircle. That would be equal to AB plus BD. This is a major arc here. We're going more than 180 degrees around the circle, so you have to give me 3 letters here. That's equal to the measure of arc ABD, or you could actually do ACD as well. So keep that in mind. This is a little hard to see. Like the light's right on it. Sorry guys, I hope you can see this. So it's just arc addition. You put 2 consecutive arcs together, it makes the larger arc. Now you can use that in your proofs, which we're actually going to have to do down here. In example 2, find each measure in circle P if we're given the measure of angle WPX is 28. I'm going to start marking the diagram with what I know. I've got a central angle there. ZPY is 38. And we know WZ and XV are diameters. Okay, so WZ is a diameter and XV is a diameter, which implies that we have a bunch of radii. So we've got 1, 2, 3. Actually, we don't know that. Or do we? No, we know that. We got a bunch of radii here. Okay. So let's see what we're asked to find. First, find the measure of arc YZ. So arc YZ right here. Okay. Well, if you know the measure of the central angle that intercepts that arc, you also know the measure of the arc. The measure of arc YZ is 38 degrees. Okay, so now finding the measure of arc WX. WX right here. We know the central angle that intercepts that arc. They have the same measure. WX, 28 degrees. Finding the measure of angle VPZ. So VPZ right here. Using vertical angles, we can see that that's also 28 degrees. Number 4, you're asked to find a major arc, arc VWX. So let's see, arc VWX. Sorry, not a major arc, actually a semicircle, right? 180 degrees. angle XPY. XPY. Okay, so XPY. So think about what you have here. We have a full semicircle. All of this. Full semicircle. Right now I'm going for this angle, XPY. If you know you've got a 28-degree angle here and a 38-degree angle here, we can get angle XPY just doing angle subtraction. So we can do 180 minus, is it still recording? Yeah, 180 minus 28 minus 38. Still recording? Yes, okay, good. And so when I do that subtraction, 180 minus 28 minus 38 gives me the measure of angle XPY, which is 114. So some of you may have been tempted to just like throw a 90-degree angle in there because it kind of looks like that. But remember, we've got some angle measures to work with in the diagram, so you want to use that information. Arc XY then. So if this is 114 degrees, then the measure of arc XY that it intercepts is also 114 degrees. Okay, now we're looking for major arc. Major arc XWY? Yeah. Okay. Major arc X, W, all the way to Y, XWY. Well, you now know that XY, the minor arc, is 114, the full circle is 360. So if we do 360 minus 114, we get 246. 246 degrees for that major arc. And finally, WZX. So let's see, WZX. All right, so a major arc from W all the way around to X. If WX is 28, the minor arc, if I do 360 minus 28, that should give me arc WZX, which is 332 degrees. Again, I have all the faith in the world that you guys probably could have figured this out on your own, but just in case, like, it's here for you. Last thing is a proof, and then you're done with lesson 5. Okay, how am I doing on time? Okay, good. So, example 3. I am going to do this as a 2-column proof. Again, if you'd prefer to do it informally, that's okay. But please try to keep yourself comfortable with 2-column proofs because on the test for this unit, I am going to ask you to do 1 or 2 2-column proofs just to keep it in order and keep it organized. It's easier for me to grade it. But if you prefer to do this informally now, that's fine. What are we given? Arc AB is a semicircle with center C. Okay, so they definitely should have thrown a third letter in there. I don't really like that. That should be arc ADB or arc AEB or arc AFB to indicate that semicircle. But we know that we've got a semicircle here of 180 degrees with the center at C. We know that arc PQ, okay, arc PQ is concentric with arc AB. So remember, we said concentric circles are basically like perfectly nested one inside the other and they share a center. It's the same thing with semicircles. They're nested, they share a center. One is just a smaller dilation of the other. We know that EC is perpendicular to AB. So EC perpendicular to AB, 90-degree angle. We also know that DC is perpendicular to CF. DC perpendicular to CF. So another 90-degree angle there. And you're asked to prove the measure of arc AD, this, plus the measure of arc QT, down here, is equal to the measure of arc EF, here, plus the measure of arc RS, in there. All right, so we know how to start. We're always going to start with our givens. So I'm going to just do a little bit of shorthand here. Givens plus diagram. Basically covering our given information in that. Reason, given. A little bit of shorthand here just to make sure I'm cutting down on the time in this video. Second thing. So let's actually throw some like numbers up here just so we have like a common point of reference for which angles we're talking about. I'm going to call this angle 1, angle 2, angle 3, and angle 4. So I got 4 angles across that semicircle. So what do I know? I now know Angle 1 plus angle 2, that's a 90-degree angle. I also know angle 3 plus angle 4 is 90 degrees, right? The two angles on the other side. And I know angle 2 plus angle 3 in pink, that's 90. And the reason I know that is because of angle addition plus the definition of perpendicular. You were given perpendicular line segments in the beginning, so we're referring back to that. Plus, I'm using angle addition. Taking a few shortcuts in this proof just to cut down on length. All right, so if that's the case, then we know that angle 1, that's the one, we know that angle 1 plus angle 2, if that's 90, then that must be equal to angle 2 plus angle 3, right? So if this equals 90 and this equals 90, they equal each other. Well, therefore, if I cross off or subtract angle 2 from both sides, I now know that angle 1 is equal to angle 3. Angle 1 and angle 3 are congruent to each other. And so the reason I know this is because of transitive property. You could also say substitution. So we've now stated that angle 1 is the same as angle 3. If that's the case, I'm going to start to mark the diagram here. If angle 1 is the same as angle 3, then that means, let's use some green here, that means that this arc is equal to this arc. Arc RP is equal to arc ST, and likewise, those are also congruent arcs to AD and EF in terms of their measure in degrees. Not length, but measure in degrees. From here, we know that angle 3 plus angle 4 must equal 90. How do we know that? If angle 1 equals angle 3, and right here, I'm referencing back to angle 2. If angle 3 plus angle 4 equals 90, now I can use what I stated here to make substitution for 3. Therefore, I know that angle 1 plus angle 4 must equal 90. Doing some substitution here. And so that's number 4. I made this substitution right here. Substitution. Okay, so then for number 5, step 5, I can now say if angle 1 plus angle 4 is 90 and angle 2 plus angle 3 is 90, that implies that angle 1 plus angle 4 must equal angle 2 plus angle 3. And again, I know this because of substitution. You could also say transitive. And so think about what we've just stated. We've just stated that angle 1 plus angle 4, angle 1 plus angle 4 is equal to angle 2 plus angle 3. So we're getting pretty close to the end of this proof. So angle 1 plus angle 4, you want to think about the arcs that those are intersecting and what we're actually trying to show. So we're trying to show that the measure of arc AD plus the measure of arc QT is equal to a bunch of other stuff. Look at the measure of arc AD. The measure of arc AD is the same thing as angle 1. The measure of arc QT, that's the same thing as angle 4. And we've now stated that angle 1 plus angle 4 is equal to something else. Let's see what that something else is. Arc EF. Arc EF, that corresponds to angle 3. And arc RS, right here, that corresponds to angle 2. Angle 2 plus angle 3. So you're basically ready to make your final statement, which I'm totally running out of space for. I'm sorry, guys. I'm going to throw it up here Your sixth statement is your final statement, your final proof. The measure of AD plus the measure of QT is equal to the measure of EF plus the measure of RS. And our reasoning for that is because of the definition of arc measure. We stated previously that the measure of the central angle is equivalent to the measure of the arc it intercepts. That's the definition of an arc measure. If you've got the measure of degrees of that angle, you then have the measure in degrees of that arc. Again, it's the measure in degrees. It's not the length, but it's the amount of degrees that the arc intercepts in terms of an angle. So that's your proof. How am I doing on time? Great, okay, I ran a little bit over. I only wanted this to be like about 25 minutes, so we hit a half hour. Hopefully by the next time I see you guys, I will be a doctor. But thanks for watching, and have a great weekend, guys. I'll see you Tuesday/Wednesday.